Eindhoven Engine is contributing to the growing global interest in smart mobility. Not only self-driving cars, which is still some way off, but also driver assist systems that are starting to appear for safer navigation of both cars and trucks. On the research front, Eindhoven University of Technology is leading the way in many respects, as Gijs Dubbelman explains in this video made during lockdown 2021.
This car is used by the University of Eindhoven to research self-driving vehicle technology, and mainly the technology that allows the car to perceive the environment around it. Just as we humans, we need to see other people, cyclists, cars, where the road is. The same holds for these self-driving vehicles. And the self-driving vehicle uses sensors, mainly cameras, radar and LiDAR. And what we research are the algorithms or the artificial intelligence that interprets the sensor data to form a so-called world model, a digital world model that represents the world around us.
Gijs, hello, great to be in contact. That's a very impressive room you're sitting in. Where exactly are you?
Thanks, Jonathan. I'm here in our lab of the Eindhoven Engine in Eindhoven, on the campus of Eindhoven University of Technology. And this is where we do our research.
So we just saw that clip and some of the more general work that you're involved in. That's quite old. Maybe you can bring us up to date.
Yeah, indeed, that video is already quite some years ago, and technology is progressing very fast. So what we're currently doing together with one of our partners here in the Eindhoven Engine, that is NXP Semiconductors, we are researching the next generation of advanced driver assistance systems.
And at the virtual CES in the USA earlier this year, they talk about what they call Bluebox technology. What's the connection with your Eindhoven Engine project called Smart Mobility?
Yes, indeed. So Bluebox, a product of NXP, NXP being a semiconductor company, basically designing, manufacturing and selling chips for the automotive industry. So looking towards the future of next generation advanced driver assistance systems, all the way towards highly automated driving, these chips, that hardware inside the car needs to innovate. And that is exactly what we're doing together with NXP. And Bluebox is their kind of R&D platform. It's kind of the brains of the car of the future. And what we do together with them is to make sure that the brains of the car of the future meet the requirements of the future. And that's what we do in our research lines here.
And who's going to set the requirements for the future? Is it the insurance companies? Is it government?
It will be coming from multiple stakeholders. And you just mentioned a few, but the first thing is to technically realize these innovations. Of course, there has been a big hype on highly automated driving, but if you need to bring that technology to the road safely all over the world, that's a completely different ballgame.
And how far are we at the moment? How far are we to get to the self-driving car? It's still a long way off, isn't it?
It's definitely still a long way off. You were absolutely right in that. If you consider this self-driving car, I get in my car in Amsterdam, I say, hey, go to Milan, go to Paris, and it's raining, it's snowing along the way, and I arrive there. And in the meantime, I watched the video and I took a nap. That is definitely very far off. But an autonomous taxi that maybe only drives from the train station to the airport, and maybe also from the train station to another train station or to a campus, with, let's say, limited possibilities where this vehicle can drive, I think that is realistic to have in 5 to 10 years from now.
And I noticed that when you see all these pictures, especially from Google, doing the self-driving car, they're always on a highway. It's always ideal conditions somewhere in California. I think you probably have an advantage at the Eindhoven University of Technology in that your campus is very similar to an urban city.
Yeah, so indeed, so we focus our research mainly in the urban context because, the industry is kind of solving the highway scenario. So we are not going to compete with industry. It doesn't make sense. So we solve on the most challenging use cases in an urban context. And indeed, our campus here in Eindhoven is kind of an urban situation with a lot of pedestrians, a lot of cyclists, not a lot of infrastructure such as traffic lights or pedestrian crossings. So yeah, it's very representative of the challenges that urban cities here in Europe pose to automated driving.
So you mentioned the Bluebox, and you mentioned that it's this giant processor. What are some of the challenges that you're working on connected with this Bluebox?
Yeah, so in the Eindhoven Engine project, we have 3 research lines. The first research line, that is headed by my colleague Marion Matters, is focusing on radar systems, so improving the resolution of radar systems, making them more robust, more capable, and so on.
Marianne Matters explains why radar in vehicles needs to advance.
So the current radar systems will see an evolution actually over time. And this evolution is necessary because there are going to be more and more cars having radar systems. So the more common the radar will become, the more interference is expected. And with the current systems, kind of the amount of cars that can have radar is limited. And in order to allow more cars to have radar, we need a different type of radar systems. And that is actually the topic of this research project. And what we do actually is we put a certain modulation onto the radar. And there are lots of different modulations, and they are used extensively, for example, in communications, where we can phone actually with millions of people at the same time using the same frequency range. Actually, what you do, you put kind of a digital code on top of the radar signal. And it is with this digital code that is then from an individual user that you can distinguish your own signal from the signal from other users.
So it's a sort of fingerprint system.
It is kind of a fingerprint, a digital fingerprint, and you can imprint it onto the radar signal. And thereby you actually can identify your own signal and distinguish it from the signal of another user who would have another fingerprint.
Okay, so what's your goal 3 years from now?
To work on a specific part of the radar system where we can show that we can indeed distinguish the signals from different users. So kind of the core part of the system will be to identify this fingerprint, because everything you do to a signal also increases its noise. So what we are trying to show is that while detecting the fingerprint, we can still do it without adding too much noise to the original signal.
My own research line is focused on vision data. So how can we get more meaningful data from a video stream? And we're also focusing on the chips inside the Bluebox to make sure that they are more power efficient and more powerful.
Can you show me what these technologies are actually seeing?
To a certain extent, I can explain that, because in the end, what comes out of the sensors is just only a stream of bits and bytes. So in that video, we see how a car localizes itself in the world. We know that GPS systems, they can be very accurate, but they are not robust if you're driving close to buildings or under trees with a lot of leaves. So these vehicles need another source of positioning, and that is LiDAR localization. How does it work? We have a point cloud map. Those are all the white points you're seeing in the video. That is a pre-recorded map consisting out of thousands of points. Then the vehicle is driving around and scanning the environment with its LiDAR system. And then it's making a registration of the live LiDAR stream with the map and computing its localization or its location in the map. And that's what you're seeing there in that video. And the color points, those are the live point clouds coming from the LiDAR.
And presumably all these sensors in the car are generating a huge amount of data. We're talking about petabytes, aren't we?
Yeah, for a modern car or car of the future that will have multiple cameras, multiple radars, maybe even 1 or 2 LiDARs. Yeah, it's indeed in the order of petabytes of data, and that all needs to be processed in real time. So you can also imagine that this computer, that is inside the car, will also have multiple processors. It's not a single processor. It's multiple processors doing lots of pre-processing that in the end goes to either a decentralized or a centralized AI system to make the decisions on basis of all that data.
But in terms of most of that data, that's going to be processed in the car, isn't it? Because otherwise you're going to have a huge problem with latency.
Yeah, it needs to be processed in the car. You cannot push all the data to the cloud and do the processing there because of latencies and bandwidth limitations. So the cars of the future will definitely be connected. So certain, let's say, more high-level functionality can and probably will run in the cloud. But the things that need to run in the car that are related to kind of low latency requirements, safety requirements, they need to be processed in the car. But it is important, these vehicles of the future, they will providing tons of data to a cloud system, and the cloud system will create maps out of it, will do kind of big data analysis to know, okay, what is your fuel consumption, what is the fuel consumption on average on this road. So there will be a huge kind of data lake in the future with all kinds of mobility data coming from vehicles. Yeah, that will be a tremendous resource for either improving safety or efficiency, doing research and all those stuff. And yeah, companies like Tesla are already doing this. They already have this fleet and are crowdsourcing all that data.
It's interesting you mentioned Tesla, because on the one hand, we hear Elon Musk saying he doesn't think LiDAR has a future in cars, whereas several news sites in the States recently spotted Teslas rigged up with LiDARs, presumably so they can keep track on what it can really do.
Yeah, indeed. So let's say I think it was already a year ago that Elon Musk made that statement, and then here with my colleagues we had the notion like, yeah, of course now these lidars are still too expensive, but in the future they will become affordable, just as cheap as radars and cameras, and then it doesn't make sense to not use lidars because they are a tremendous source of information.
Okay, so show us an example where AI plays a role.
Yeah, so what you see in this video is the process to create such a map that the vehicle needs in order to localize itself. So that basically involves, in our case, just driving around with the vehicle, and then the vehicle's collecting all those LiDAR scans. All those individual LiDAR scans go into a big optimization system, which is called SLAM, or Simultaneous Localization and Mapping. That is then fused with post-processed RTK GPS to create a very accurate point cloud map. And that is this white point cloud map that you see in the other video. And once we have this point cloud map, the vehicle can drive autonomously in that environment. But without this map, it cannot drive autonomously. So the map is really a key enabler to drive autonomously. Of course, knowing where you are is not enough. You also need to see all the other road users around you. And that's what we do as humans as well. So what we do with our video-based AI analysis is to analyze those video streams and to be able to detect vehicles, pedestrians, but also where is the road, where is the sidewalk, where are trees. Actually, this neural network for each pixel can identify what class it is, up to around 30 different classes. For each pixel, it can say, okay, you belong to car number 1, 2, or 3, or pedestrian 5, 6, or 7. And inside those objects, it can also distinguish where is the head of the pedestrians, where are the hands and the legs, and so on, in order for another AI system to predict, okay, where is this pedestrian going? Is it going to cross the street, yes or no? Or is this car going to turn left or going to turn right?
Now, we see systems already that I think BMW has them. They will spot a pedestrian stepping into the road and immediately apply the brakes.
Yeah.
So are these systems similar to what you're talking about, or is it?
The goal is similar. The goal is similar. We want to prevent accidents. Now, what is the key problem is to predict the future. Predict what other road users will be doing in the future. Because if you can predict that, you can anticipate on that with your own actions. And currently, it's still extremely challenging, for instance, in urban conditions, to predict for AI what everybody is doing in the future. And we as humans, we are so trained to look at our world and to make sense out of it. For us, it's so natural, but for AI, it's so tremendously difficult. So that's also why most kind of collision prevention systems today are reactive. So something is standing in front of the vehicle, I need to brake, but not really predictive, not saying, okay, I see this object, it's not in part of my vehicle now, but it will be there in 1.5 seconds from now.
What is your preferred future? How do you hope this is going to go forward, let's say in the next 5 years?
So what we hope with the Eindhoven Engine is that we can have a lot of follow-up projects. We are already working together with NWO, that's the organization, our governmental organization that subsidizes research, to already think of a follow-up of our Eindhoven Engine project. And we are constantly exploring new opportunities to do research together with our partners. So my future would be here, that we have here in the Eindhoven Engine building, we have, let's say, a team of 10 PhDs and PDNs working on the vehicles of the future.
But of course, there's a lot of research going on in other parts of Europe too. I'm thinking of Munich and the huge auto companies too. Where does Eindhoven fit in, and how can you really compete with what others are doing?
Yeah, that is a very important question, because if you consider all those investments all over the world in this field, hey, how are you going to compete with a relatively small university and then a relatively kind of, in the bigger scale, small lab? The answer to that question is focus, focus, focus. And cooperate. So together with our international partners, we have discussions also with the German OEMs and the German tiers. So this is where we are going to focus on. This is what you are doing, and this is how we are going to bring it together in this European project settings.
So guys, if people are watching this and interested in getting involved with what you're doing, what should they do?
Yes, please do reach out to me via email or via my LinkedIn. And we're happy to do demos. We used to do tons of demos before COVID, almost weekly. And we hope we can do all those demos again after this situation has cleared.
My thanks to Marianne Matters and Gijs Dubbelman for those updates as we start 2022. Check back soon for more developments in smart mobility from the North Brabant region of the Netherlands.